Hello and welcome back to another video. Today we'll be doing logarithms. Logarithms are the inverse function of exponents. So like how inverse sine is just the inverse function of sine, log is the inverse function to exponentiation. Okay, so let's look at some of the identities that we need to know. This looks like a lot, but let's zoom into this, okay? So first thing, this relates logarithms to exponents, okay? If you have a to the power of x equals to b, this means that x equals to log AB. So how do I remember this efficiently? Okay, I'm actually going to make use of applying log on both sides. And after I apply the log on both sides, we can see that this equals to log AB. Actually, we'll see this later, that this thing on the left-hand side is just equals to x. For now, we just keep that in mind. Okay, a must be more than 0, a cannot be equals to 1, and b must be more than 0. This is such that the logarithmic form is defined. Before we continue, how do I read this? This is actually just log base a of b, okay? This right over here is your base. Alright, the next thing we have over here is log base a of xy will actually be converted into log base a of x plus log base a of y. So this is kind of like a product to sum. Again, this is in your formula booklet, okay? For the next one, we treat it kind of similarly. A quotient, log base a of x over y, becomes log base a x minus log base a y. Alright, the next one, when we have a power, we can bring the power out for it to become m log a of x. Alright? Keep in mind, this is not the same as log base a of x whole thing square. This is just log base a x square like this. Alright? And finally, this formula over here is called the change of base formula. Okay, if we want to change this to a different base, we'll use this formula. What I do is remember that this x over here goes to the top and the base here goes to the bottom. Okay, I know that was a lot to take in, but we still have a little bit more to go through. So this is the graph of y equals to log base a of x. As you can see here, there's a vertical asymptote of x equals to 0. That means as this graph approaches closer and closer to 0 on the x value, the graph goes to, in this case, negative infinity for the output value of y. Alright, and one more property of the graph is that there's always a point at 1, 0 for all values of a. So we can note down a few properties actually. First of all, we know that log base a of 1 is just 0 because we know that there's a point 1, 0 on this graph. Okay, the next one, log base a of a is just equals to 1. And finally, this one, which will come in quite useful, not now though, e to the power of ln x equals to x. Or in general, a to the power of log ax equals to x. In case you're not familiar with what ln x is just log base e of x. Okay, let's do this question. Find the values of x that satisfy the following equation. Okay, we have this. So whenever it comes to log questions, if I want to solve for x, this usually means that I want to take out the log in some way. If you realize, if both sides have log 2 of something equals to log 2 of something, I can actually cancel out the logs. So that's what we're going to try to do. So first, we have the 2 there, okay, 2 log 2 of x minus 5. What I can do is I can bring the power up so that I can have log 2, just log 2. The next one, we see that we have the sum of something plus something. So we can actually utilize this formula over here, such that a sum can become a product, okay? Just combine it into one log. How do we do this? Okay, first of all, we need to convert this 3 into log base 2 of something. So what is 3 log base 2 of? 3 is just log base 2 of 8. Why is this so? Because log base 2 of 2 cubed is 3. Because we bring the power out and log base a of a is just 1. And now let's apply this product to sum formula, or in this case, we are converting the sum back to a product. We'll get log 2 times 8 times x plus 1. So over here, we can just simply cancel out the logs. Okay, when you reach here, you can just simplify and make a quadratic equation. So let's zoom into the answer. We'll get x equals to 17, we solve this quadratic, or x equals to 1. Can we keep both answers? Actually, no. We'll realize that x equals to 1 is wrong. We have to reject it, but x equals to 17 is not rejected. So why do we need to reject x equals to 1? Again, when it comes to logarithms, it's very strict. We have to make sure that this is fulfilled. Oftentimes, this base rule is not too important. Like, usually they will not give you a negative base of a log. That will usually not happen. But more importantly, we have to remember that the inside must be more than 0. And why is this true? This is true because if we look at the exponential graph, the graph of an exponential function, for example, y equals to e to the power x, it will never touch 0. That's why this has to be more than 0. If we see over here, the output value is always more than 0. Alright, so in this case, why is 1 rejected? Because if we substitute 1 back into here, we realize we get log base 2 of -4, which is just wrong. So our final answer is just x equals to 17. And here's the summary sheet for exponents and logarithms.